Hello Year 12. For today's lesson, I'd like you to be having a look at the next couple of questions in your work booklet on critical paths. The HSC question here is the starting point. It's straight underneath our last lesson, which looked like these, our float times, okay? So you should have had those completed last lesson. So I want you to start by giving these HSC style questions a go, okay? And you can skip the flashback question for now. We'll come back to those. Keep going down through these ones as well. And I want you to pause the video, give all of these a go, and then press play once you have gotten up to network flow problems, okay? So what I'm going to do now is I'm going to jump straight into completing those questions. So pause the video, give them a go, because now I'm going to go through the solutions. And what I want you to do is be marking these as though you just sat them in an exam. Okay, it's basically a summary of everything we've done so far. So here's your chance to pause the video. So the first question here, we had to identify the number of activities with exactly 2 immediate predecessors. So remember, immediate predecessors are the activities that happen directly before it. So all you're looking here is for an activity that has 2 activities that were done immediately before it. So straight away I can see here I've got 2 lines coming into this vertex. So activity I is one of them. And the second one is going to be, I can see here, activity J, because we've got 2 vertices coming, 2 edges coming into it. All right, the next one is going to be okay, so hopefully they were your EST and LSTs. So now identifying my critical path, I go along the edges which have a float time of 0. So there's your critical path, okay? So the actual answer for the critical path is BEIL, going along those activities there. Okay, so now it's more just problem solving. If activity E is reduced by 1 hour, identify the 2 new critical paths. So the best way to do this is I would always either pick a whole different color pen or redraw the network, because it's essentially, you gotta start from scratch from activity E at least onwards, okay? But it's best to just start it from scratch again. It's easy for me because I can just use my eraser tool, but I would use a different pen and redraw blank boxes or sketch your network elsewhere. But it actually didn't turn out to be too bad to just cross out if you needed to. So you can see here, by shortening activity E by 1 hour, so that's this part here that I've done, made it a 4. So what I thought straight away is, okay, what's that going to affect? Well, that's going to make this EST up here a 7 rather than an 8. And then I followed through all the way till 19. It would still end up being 19. So I could see that when I went from over here and I was at 5 and I plus 2, that gave me 7. But then now also following this route, going from 3, adding the 4, that gives me 7. So that's why there's 2 critical paths this time, okay? Because when we would backward scan now, we'll find that it could go either way. So your 2 critical paths are those 2 routes labeled. And I think it asked for, now notice how the question says 2 new critical paths, okay? So the BEIL isn't the old original critical path. So I've identified one of the new critical paths. So if you went back through and redid it all, you'll find that you'll also have a critical path along this route. Because, have a look, 19 minus 8 gave me 11, 11 minus 3 now, well, that means backwards scanning, I get 8. 8 minus 6, well, that's going to give me 2 on the bottom, and 2 minus 2 gives me 0. So there we've got a 0 float time. So my best advice for questions like that where they adjust one of the time slots, redo your network, because you can see, like I've showed you here, how easily it can get messy, or you could miss something. But that was your last critical path, CHKL. Okay, next one. Skipping the flashback question. All right, give this one a go if you haven't already. Okay, filling it all in with our EST, LSTs. The original graph had a critical path of AD. So now if we want to limit B's activity be only completed in 5 minutes, how much sooner would we complete the overall task? So now redo your boxes and either redo your network or draw them in a different color. But now let's redo the whole thing with a 5 on activity B. So we have 0. Now I shouldn't skip ahead. Okay, and what do you find? Well, it didn't change the critical path at all, did it? So what happens is the answer is you wouldn't complete it any sooner. The idea is, or the quicker way to know, is if they ever adjust a time slot that is not on the critical path, the overall time will not be changed. And write that as a note to yourself in your book or on your booklet. I'll say it again. If they change the time of an activity that is not on your critical path, the overall activity time of the network will not change. Okay, so there's a good example. B is not on our critical path, so the overall time to complete this activity did not change. So from here on in, that's how you can spot it straight away. So if B was on the critical path, then yep, go and redraw all your boxes. But when B's not on your critical path, you don't have to take that time to do it again. So that's my explanation there. The overall time of the task would not change as activity B is not on the critical path. Okay, so I've gone through and I've put my ESTs and LSTs on. Then I've gone through the float times. So hopefully all of that so far is okay with you. If they're not, you need to go back and revise previous lessons. So what you should have had are these answers. And now I've just sort of summarized it, which is perfectly fine to do. A, B, F, and H all have a 0 float time. And C and E have a float time of 3. And D and G have a float time of 2. Okay. All right, so the next part says, suggest 2 ways we could make this task quicker. So, what's important? Let's look at our critical path here. So, going along all the float times of 0, there's our critical path. So, following our critical path, if we want to list a way we could make this, what was the wording? Quicker. The way we would do it is to reduce the times of an activity on the critical path. Okay, so if you need to make a task be quicker, we reduce the times of activities on the critical path. And think about it logically. It makes sense, because if I reduce the time of, say, activity G, it doesn't matter. It makes no difference, because the critical path is the one that takes the longest. Okay, it's the one that holds everything up. There's no time to muck around there. So it doesn't make any difference. Everything still gets done in the same amount of time. So we reduce an activity that is on the critical path. All right. Now, my number 1 tip is to reduce the activity at the very beginning where any critical path could pass through. What I mean by that is, so notice how activity A, no matter where the critical path is on this entire diagram, it's going to pass through A. The reason I choose that, so reduce A would be one answer. Now, the reason I choose that is because let's say I didn't choose A. Let's say I chose one of the other activities on my network. Let's say instead I thought, okay, what if I just reduce B? So if I reduce B, what's going to happen is if I reduce it too much, another critical path will be formed. Okay, think about that. If I reduce B's too much, what may happen, and we'd have to test it with numbers to see, but what may happen is a critical path might be formed along C, E to H. So then reducing B won't make a difference, because if that's reduced enough, it won't be part of the critical path anymore. So that's why if they ever ask you what you should reduce A, the path that any critical path has to pass through. But they've purposely asked for two things here to keep that in mind for you. So two ways we could complete the task quicker. If we reduce, my second answer would be to reduce B, F, or H, but I would let the marker know that you know it can only be reduced by a small amount. So there's my typed up answer. Reduce activity A or another activity on the critical path, such as B, F, or H, ensuring that it wouldn't affect the critical path. Okay. So I think it's a good answer. It tells the marker that you really have a deep understanding of that. Okay, next one, your minimum completion time. Hopefully you got 22 hours. So your minimum completion time, that's what our next exercise is. But it's nothing new. If you think about what it means, it's the minimum time you could finish this whole task. So we know that our ESTs are the earliest start time. So the minimum completion time is going to just be the finish EST. Okay, so I'll say that again and make a note in your booklet. The minimum completion time of a task is just going to be the finish EST of your task. So that will always be the minimum completion time. And it makes sense because it's the earliest start time if there was another activity after it. But there is no activity after it. So that's the earliest start time if there was. So therefore, it's the minimum time or the quickest time you could get all of this task done. Okay, I'm just going to talk through the next one. Suggest a way that we could complete the task 3 hours sooner. Well, what do you know? Remember my little tip from last question? We have A and B on that nice beginning line that any critical path would pass through. So I would say to reduce A or B by 3 hours. That would be my solution for that one. Okay, this next one here says list the activities that could not be delayed if the project is to be completed in the shortest time possible. Okay, so what it's saying is what activities could you not delay at all if you needed to put a hold on some activity to do something else first. And your answer is just the activities along the critical path. The reason is because they have a float time of 0. Okay, so we know a float time means there's no time, there's no wriggle room there, no time to chill out, no time to delay. It has to be done and then the next activity started straight away. Otherwise, the overall time of the whole task will be affected. So here where we will need to list the activities that cannot be delayed, if we need to finish this task in the shortest possible time, it cannot be those on the critical path. So go through, do your ESTs, do your LSTs, have a look at your float times and identify your critical path, and you should get an answer of C, F, H, M. If you don't get that answer and you just can't work out, let me know and I'll put up my solution to my EST and LSTs. But they've done in a slightly different way, but that red line there shows the critical path. So the final question. It wanted you to identify the critical path. you should have got an answer of A, B, D, F, G, I, K, L. And now we needed to determine the latest starting time of activity E. Okay, so looking at that, the latest starting time of activity E, it's just reading off the diagram, and you can see that the latest time we have just before activity E, so that's the one, the latest start time of activity E is going to be 12. Okay, what activity had the longest float time? So that was just a matter of going through each activity, labeling the float times, and you should have got an answer of J being 5. Again, if you didn't get these answers and you can't work out why and see any mistake you've made or anything, let me know and I'll put up my full solution. Okay, it is possible to reduce the completion time for C, D, G, H, K by employing more workers. These 5 activities can be reduced by a maximum of 2 hours. What is the new minimum completion time for the project? Okay, this is an interesting question. And what I've just done is I highlighted in orange the tasks, the activities that all get reduced by 2. And then I've also highlighted in blue the critical path. So, my best advice for this question would be to redraw your boxes now and do your EST and LSTs with each of those orange activities, reduce those times by 2, okay? And then, once you do that, redo the whole critical path, and then your answer to the new critical path, if it is a new critical path or whether it's the same path, but your answer, your EST at the finish, will be your final answer. So, when you do that, you'll get an answer of 29, okay? So, I'll just say that again. So, what you'll do is go through and every single one of those activities that have been mentioned here get reduced by 2, and then redo all your EST and LSTs, okay, and then it'll just be your new answer that you get as your final EST, which will be 29. Once again, if you can't get that answer, let me know. I'll put up my solution. See how you go. Okay, so I want you to stop there now. Today's exercise is going to be, so exercise 10F, and you're just doing the last 2 questions, question 6 and question 7. So that was exercise 10F, questions 6 and 7, please. Okay. Let me know how you go. I apologise, the video's a bit gluggy. My stylus pen is broken a little bit, so I need to get that fixed. But email me if you have any questions.